Hello, my name is Chen Jian. Today I'll be doing a presentation on the EM3 project. So let's get started.
I'll now move on to talk about the workings for the Euler formula on paper. So this is the given formula by the assignment, and this is the value. This is the formula that we'll be using. Yeah. So whereby you will find the f and xy value equals to x squared plus 1 divided by y. So by using the step size value of 0.2, I'm able to find out for my this value, for my f and xn plus xy value. So this is just basically substituting the value of x, the step size value, into the formula to get each of these values. I'll move on to talk about the graph. So this is the graph. So these are the values that I get from calculating the step size. So the n value is 1, so therefore the graph is going up, and therefore the y value is 1.9095. Formula to use for, so this is the formula that we're using for the Euler. Therefore the approximate Euler value is this value.
Okay, right now I will show you how to derive the value from using Excel. Okay, so by using the step size 0.2, so therefore I get my y value, which is this. I just put in the y value, and then this formula is because I'm using x squared plus 1 over y. So x squared is A12 column using A12, and then y is just this one value. So therefore over B12, B12 is the value of y, so therefore I get this. So therefore, by substituting the value of x into the formula here, I'm able to find the value of my f and x and y value. So basically it's all this column to find all these value. And then for the y value here is basically adding the step size and multiplying by the previous f value, f and xy value. So to find my y value for the rest of the step size. For this value here is not required, as step 4 value of fxy is 0.9542, which round off to approximately 1. So therefore we found out that the estimate Euler value is estimated 1.9095.
And now I will be explaining on the steps to find your initial value y0 equals to 1, and finding the approximate value of y1. I'll be explaining the formula using the general solution to get the answer. So from this we derive with this equation, dy dx is equals to x squared plus 1 over y. And then the first step will be separating the variables, so separate the x away from the y, so therefore we'll get this value. We'll be integrating both sides. So by integrating the equation, I will derive with this value here. Solving for y, so I multiply 2 to take away the denominator, and therefore I come out with this. And from here, I will simplify. So simplify, I will get this. Right, simplifying this and applying the initial condition. So by substituting the value, I will get this equation here. I'll move on to talk about the graph between using the Euler line and the analytical methods. Okay, so using the analytical line method, as you can see, there's a very slight difference that the Euler line is more curved, the graph is more curved as compared to the analytical method. So this is the difference. Using the Euler method is more accurate as compared to the analytical method.
Thanks for listening to my presentation.